Hello, everybody. I'll give you a brief overview on a few topics we are working on at PVsyst, on things we've implemented in the current versions, things we are planning to implement soon, and also some work we are doing more on the long term. So here, currently we are, so last time I presented here at the workshop was August last year. At that time, we were at PVsyst 7.2.18. Today, we are at PVsyst 7.3.4. So we are what we call major version further. So the second digit is what we call the major version. We are now in the version 7.3. And 7.3 introduced an upgrade to the Metronorm 8.1 libraries and the single line diagram. And I'll be talking about some topics I chose that are listed on the right side, which cover things that were done between the 7.2.18 and the current version, and what we'll plan to do for 7.4 and for the versions 8. So one thing we permanently update are our databases. So as I said, for 7.3, we went to Metronorm 8.1 libraries. The weather data in PVsyst is an input that the user has to supply to make the simulation, but we have built into PVsyst Metronorm libraries that allow you to get a typical year for any point on the globe straight away, so you can make a simulation if you don't have yet external data sources for your site. And we improved also the importing of other data sources like 3E and the NATO database, which covers Japan. We have APIs in the software that access the provider Solcast, Solar Anywhere, and SolarGIS, which make it easy to get those data quickly into PVsyst also. But for those APIs, of course, you need an internet access. For the built-in Metronorm libraries, you don't even need that. Then apart from the Meteo databases, the weather databases, and the weather data, we have also the components, mainly the PV modules and inverters. So we keep regularly adding products to that. These are products or information we get from the manufacturers themselves. We verify them at PVsyst and then we integrate it. There's a special category of components, which are the power optimizers, which are very different in their technologies, so need to be implemented individually for each brand. And recently we have added the Huawei optimizers to our devices that you can simulate, and also the SunGrow optimizers will be soon available in PVsyst. We also keep improving the guidance and verifications of the PAN files. And it's funny, I just wanted to put a screenshot in there, but it's curiously exactly what Jim was showing this morning. So if we find a PAN file that has a suspicious incidence angle modifier, you get a message in PVsyst that guides you and then puts your attention to exactly those facts. So we try to provide also this kind of guidance in PVsyst that you get a critical view on the type of input you are using. Another very important topic is to allow PVsyst to be easily usable also for large systems. It has always been our aim to be able to simulate all sizes of PV installations. And nowadays, the large installations are getting more complex. You've seen some examples before today, where in former times, the large installations were flat things in the desert, and now they are becoming installations on hilly topographies. And all this causes complications or makes it more difficult to handle this, be it in the 3D model, be it in the simulation calculations themselves. And so there are also more and more other software packages which allow you to implement your tables on a terrain like PVKs or Helios 3D. And we are improving the interfaces also to those products. So there are different formats that you can import into PVsyst for the 3D models, VAE, 3DS, and PVC. PVC is a sort of extended format that allows to describe already PV surfaces and tracking devices. So this makes it very easy to import 3D designs which are already working in PVsyst. But if you have a modeling software or a design software for your site which does not support this PVC format, and you have these more generalized 3D descriptions. In PVsyst, we are also implementing tools which allow you, for example, to convert rectangles that you've imported from your design into PV surfaces, or even transform them into tracking surfaces. So all this aims at making it simpler to handle large and complex systems in PVsyst. For the trackers on the bottom right, so you see another example for the calculation of the diffuse shadings. If you have a very large system, it becomes very slow to use all the system to calculate the amount of diffuse shading. And what PVsyst does, it chooses a representative set of tables and does the diffuse shading calculations on that. And it has always been like this, but you would never see this as a user. And sometimes this automatic choice was not very well done, especially in systems which were spread out in an irregular way. And now you can see the choice of PVsyst, and you can even act on it. If you're not satisfied, you can select the group of tables that should be used for this kind of calculation. So these are all kind of minor improvements, I would say, but which make it possible and easier to handle these large systems in PVsyst. Another topic we are working on are what we call the electrical shadings. So electrical shadings are the fact that if you partially shade a string or a PV module, the current in the entire string or module is impacted, not only the one of the shaded cells. This is what we call electrical shadings. And in PVsyst, we have a model which we call the module layout tool, which allows you to calculate the IV curves on a submodule level. So a submodule is for us a group of cells which is protected by a bypass diode. You see this example if you have a partial shading of your PV module. PVsyst will build up, will calculate the shadings on each of these groups of cells and build up the complete IV curve based on that. And then the modules are combined together to strings and so on and so forth. And to do this correctly, I mean, if you calculate on the submodule level, you need to know the size of the cell. And in former times, the cells were always square, so you just needed to know one dimensions. And now with the advent of twin half cells and shingled modules, you have two different length and width. And we implemented that in PVsyst to account correctly for these shading effects. And there are many new modules. So the twin half cells come in different declinations with groups of 5 submodules or just 6 submodules. And you can introduce that in PVsyst, and the electrical shading calculations will follow. So this is the highest level detail calculation for electrical shadings in PVsyst. But for very large systems, this becomes quickly quite expensive in terms of time of implementing it in the model and to run the simulation. And for this, we have what we call simplified models for the electrical shading calculations. So the top one, the module layout, is the detailed one, is our reference, what we consider the most detailed and precise calculation in PVsyst. And then we have these 3 simplified models. The first 2 are what we call according to strings. And there you have to define just the strings in your 3D model. And the shading conditions of the string will determine the IV curve of those strings, and we can work with that. They come in 2 versions. One is called the slow one, where we do the detailed calculation of the shadings in each simulation step. And the second one we call the fast. It uses lookup tables, which are pre-calculated and which make the simulation much, much faster. So for very large systems, this is what you need to do. And then we have also for very preliminary calculations, 2D modules, which are based on sections of your rows and calculate the row-to-row shadings based on that. They also allow you to calculate these electrical shading effects. And these simplified models, we have been matching them more and more to the module layout detailed calculation. So on the right side, you just see an example. This is a twin half cell with a single row. You see the electrical shading goes in steps. So as parts of your cells are shaded, you lose entirely a production of these submodules. And you see that in version 7.3, we had a slight discrepancy between the simplified models and the module layout. And we've been correcting that to get more precise results also with the simplified models. Then, as announced already last time in this workshop, the single line diagram has come with version 7.3. And the single line diagram allows you to visualize the PV system better. So on the left side, you see basically what you introduce in PVsyst to define the PV system, the choice of inverters, string configurations, transformers, cabling, etc. And now you can see the result in a tree view, like in the middle, which we call the editing view. And on the right side, you see the diagram that you can also include in the report. We still need to include the power optimizers in this single line diagram. And on the long term, we will use also this tree view to edit directly the system. Right now, you can only collapse and expand some of these strings to get a nice rendering on the report. But on the long term, you will be able to edit your system directly in that view. And this will be much more comfortable for complex systems, especially. Then grid injection limitation has also been improved. So grid injection limitation is just that you have a power limitation at your injection point and you get curtailed by your grid. This is non-trivial for very complex systems where you have different DC-AC ratios on different inverters. Yeah, so if you have many inverters and different inverters have different DC-AC ratios, and in the worst case, different MPPT trackers have different amounts of strings, it quickly becomes complicated to dispatch a curtailment to all these different inputs and to do it right. And we noticed that for some complex configurations, we were not doing it 100% correctly, and we improved that. You see there on the right side an example where we plot the AC power against the optimum maximum power point power, yeah, that you could achieve. And you see basically it follows linearly, and then you have the first kink where the first set of DC-AC ratio inputs starts saturating, and you have only a subset of MPPT inputs which can still increase in power, and then when it becomes completely flat, you hit the grid limitation. So these calculations have also been improved to get more detail and more precision on that aspect, which is important because as we've seen also today, the DC-AC ratio keeps increasing on the systems. Finally, what I want to show you is the sub-hourly clipping losses that we've been talking a lot about already today. So the sub-hourly clipping losses is just the fact that PVsyst is an hourly simulation. So the simulation is based on hourly steps. And if you are operating close to the clipping level with your average, you can miss sub-hourly fluctuations. And although the fluctuations go both ways, so up and down, in the end, you will always underestimate your clipping losses, yeah, for upwards and also for downwards fluctuations. And we've developed a model which is based on an analysis of minute level data that can correct for this then in the hourly simulation. So basically, when you generate your hourly weather data set to run the PVsyst simulation, PVsyst will, if it's the original data is minute level, PVsyst analyzes those data, stores additional values together with this data set. And then for any orientation, for any configuration, you can use this information to estimate correctly the clipping losses. And on the bottom right, you see the results. So the histogram towards the bottom shows you the bias we had in the hourly simulations before applying the sub-hourly corrections. And the top one shows that we brought it back. We were still left with some bias in those results, but we analyzed this. It's a poster from Michele Oliosi, you find there on the wall. And our conclusion right now is that this is an artifact coming from applying the Perez transposition to minute level data, which is probably not 100% correct. So we think that our correction for the clipping losses is complete, and we will implement that in PVsyst version 8. And then just a short overview of other developments that are ongoing. We have many minor improvements in the result and the reports. You can add notes to your simulations that can show up in the reports. You get detailed summaries of issues that were encountered during the simulation so that you can see where suspicious results might be coming from. We've improved our financial analysis to include more variables and to allow more details. So this is the top. These are things which already exist. And the bottom part of the slide is the future. So one important improvement that we'll be doing is related to orientations. So this will be PVsyst version 8, which is foreseen for later this year or beginning of next year latest. And basically right now in PVsyst, you have a limitation of 8 different orientations that you can have in a simulation. You have a limitation that you cannot mix trackers with fixed tilt. You can, if you make a bifacial simulation, you can have just one orientation, and all these restrictions will go away with version 8. So you will be able to have as many orientations as you like. You can mix orientations on the same MPPT input. You can mix trackers and fixed tilt if you like. You can mix bifacial with monofacial, and you can have different bifacial models in the same simulations for different orientations. So it will become much more flexible, and it will go in the direction of what I said before, to allow to model large and complex systems with PVsyst. We are also working on a general bifacial model, which is based on the 3D drawing. Yeah, so right now we are using a simplified 2-dimensional model, but this will be generalized to use really the 3D drawing that you have for the shadings, also for the bifacial calculations. This is not version 8.0, but a following version. And then there are minor improvements, like we will include a solar glare analysis because some users are asking for it. We have implemented a tracker wind stow position, and we are working on the PVsyst command line, which will allow you to operate PVsyst in an automated way from batch scripts. Yeah, so you don't need to use the user interface to run the PVsyst simulations. So we have prototypes for that, but no real timeline when this will be published. And yeah, this brings me to summary. I listed here the topics I've been talking about. Maybe a last comment for the last line in there. We are also trying to improve our user support. So we have training sessions. Before the pandemic, they were on site in our headquarters. Now they have been transformed to online training that we do regularly, that you can book. We are producing a lot of video tutorials, and this is really a big success because they are very, very, very well used. We are trying to publish these tutorials or advertise these tutorials also on social networks and also on Chinese platforms, because we have observed that we have more and more users in the Chinese, in China. Okay, so this was the overview of what we are working on, and I thank you for your attention.
Thank you, Bruno.